today, guys, today's just more of the same, okay?
Good.
Ish. We are throwing in one more thing. We are going to dilate some. Yesterday was all straight figures. There was some triangles. There was a weird quadrilateral that has no shape. Today we are going to do some curved ones, okay? So let's say I want to dilate this heart, okay? Actually, I'm going to do a circle. You have a circle on your assignment. I'm going to do a circle. And I'm choosing a circle on purpose. And my circle isn't super circular, but that's okay. Oh, and we're going to just dilate this with r equals 2 just to keep the math easy. Does that work for everybody? Mm-hmm. Okay. So there's something important. Now, when you were dilating a triangle, how many points did you have to move?
3.
3. And then you just take your ruler and connect the dots. Is it going to cut it with 3?
No.
If I try to dilate this with 3 points, let's say I have 3 points over here, what I'm going to end up doing, I'm going to draw myself a baked potato.
Or a rock.
Or a rock. Right?
The rocks are cool.
Like, is it okay to turn a circle into a baked potato?
No.
Or a rock. It's a little bit more rock-like than a potato, but I've seen a lot of baked potatoes come from a lot of students.
Actually, I think
I recognize that we live in Southeast Idaho, and potatoes are near and dear to our hearts, but please don't turn your circles into potatoes.
Or dinosaurs.
Dinosaurs or anything, okay?
Or rocks or...
You only have like 4.
How many points do you need to use? Ronan, what do you think?
4.
Ronan thinks 4. What do you think, Casey?
I also think 4.
You also think 4? I think 4 is actually probably not enough.
What?
80 bajillion.
Okay, so
At least 8.
okay, so let's talk about this. So these guys are saying 4. Honestly, I don't think 4 is enough.
I do.
I say 80
Braddock
bajillion.
is over here saying 80 bajillion, which is 8 times 10 to the 37th. Okay. Would 8 times 10 to the 37th get the job done marvelously well?
Yeah.
It would be beautiful. It would also take him until next year. Okay?
Or until 10 years.
Or until 10 years. I mean, not forever. Eventually he'd do it, but it would take, he'd probably die before he finished this. Ethan, maybe 8? As many points as you need to not have it be a baked potato. Okay, so 4 is really honestly probably enough. Probably not enough. I saw some pretty messy dilations with your triangles and your squares. I don't want to be seeing messy dilations with these circles. So maybe you have to use
80 bajillion.
Maybe you have to use 8. Don't do, 80 bajillion. Like, it would be gorgeous if you use. Are there 80 bajillion points on here?
No.
Yes. There are infinitely many points on here. You could dilate infinitely many points. Is that actually realistic for us in our world today?
No.
No, I want you to get out of here with no homework. So let's do, like if we do 4, but the nice thing is usually for most of these, you get a 2-for-1 because look at this. My ruler crosses this in 2 points. Unless you do the very, very edge, which you're going to need to do some edge ones just to get those edges. But it crosses in 2 points. So it crosses at 18. This is when, remember how I've been saying, don't lift up your ruler until you've plotted that second point. This is where it's really, really handy because you can get a 2-for-1. R equals 2.
For 1.
This is 18. What's 18 times 2?
36.
36. Okay, so I'm just going to plot this right there. Okay. And then this is not as pretty. It's 25 and a half. So 25 times 2 is 50.
51.
So 25 and a half is going to be 51. Okay. So then I keep it and I just move it. I am going to get this edge one. Looks like that's 23. 23 times 2 is 46. Okay. And then I just kind of go. So this is 15. This other one was, I don't remember what it was. So that's 15, so that's 30. And this is 28 and a half. 28 times 2 is 56, right? So 56 plus 1 is 57. So that's going to be 57. So, and then I'm just going to move it a little bit. I have 14 and a half, so that's 29. Oh, look, they're going to intersect a little bit. That happens. This one's actually 29, like it's right on the other one. 29 times 2 is 58.
How do you know this stuff in your head?
She's a math teacher, Ronan. Don't judge her.
Like, I can just do it in my head really fast. Some of it is, okay, so like 29, when I said 29 times 2, well, I know that 30 times 2 is 60. So I just subtract 2 and then I get 20 and then I get 58, right? This is that mental math. All right. So 15 and a half times 2 is 31. 25 and a half times 2 is 51. If you can't do it in your head, I don't care. Use a calculator. And then this edge one, 19 and a half times 2 is 39. So I actually have, let me erase this random number 4. How many points did I end up with? I didn't count how many points I needed, but I just kind of moved it a little bit. I ended up with 1, 2, 3, 4, 5, 6, 7, 8, 9. I ended up with 10 points.
I was right.
Okay, so could I maybe do it with 8? Maybe, but I felt like 10, and then I just connect my points, and I make it a nice circle. Would more points make it easy for me to connect my circle?
Yes.
Yeah.
You could easily make that into a ladybug.
There we go.
You could
Is
make-
it still a circle?
Yeah. And you could
If I dilate a circle, is it still going to be a circle? Yep. Nothing is going to change. I did have one student tell me, it wasn't in this class, that the angles did not change on his circle. There are no angles. I see no angles, so nothing's going to change.
Yeah, they didn't change because there are no angles.
Okay, so now here's the deal. So this is, we're going to call this circle,
Ladybug.
no, Optimus. We haven't had Optimus for a while, and this is Optimus Prime. Honestly, I think it looks more like a tick than a ladybug. It's a tick.
It is.
You know how you can tell it's a tick?
Because that's 8 legs.
Ticks are arachnids and they have 8 legs. If you have a critter on you with 8 legs, you need to get it off of you because it's either a tick, a spider, or a scorpion. And you don't want any of those on your body.
Unless it's
spiders.
Well, what about a jumping spider? Those are
All spiders are venomous. Some will kill you, some will not. But all
What about
spiders
jumping
are venomous.
spiders?
They're venomous. They won't hurt you.
They give you no.
They don't have enough venom. Their venom isn't going to really hurt you, but they're all venomous. I mean, that's how they catch their prey.
But they are like the jumping spiders are also very
Are
tiny.
they all poisonous though? Like, can you eat a spider and be fine?
I don't know, but I do know that they're all venomous.
Well, you can eat a tarantula and be fine.
I don't know, but if you ate my
That's what you
tarantula,
said.
you would not be fine.
Hey.
I'm just gonna. Do you understand what I'm saying? If you ate my tarantula, Braddock, you would not be fine because of me. So there's that. So I have Optimus and I have Optimus Prime. Okay, I dilated Optimus with R equals 2 to get it to be Optimus Prime.
Tick and tick.
What if I wanted to take Optimus Prime back and have it be where Optimus is and at Optimus's size?
It'd be Optimus double prime.
It would be Optimus double prime, but what would my R need to equal?
1/2.
Why? How do you know that?
Because you'd basically be taking that 2 and just playing the Uno reverse card.
You're gonna flip it. Actually, it's called flipping the fraction or doing the reciprocal.
Wait, there's an invisible 1 there.
There
It's
is an
over 1.
invisible 1. This is over 1. So if I multiply it by 2 to get it there, then I multiply it by 1/2 to get it back. Should we do that with some hairier numbers? Okay, let's do one. We're gonna actually do one of these. Most of these, you're just gonna tell me what it's coming back to. But let's say I'm gonna do a triangle. Why am I using a triangle?
Because you like triangles.
Because it has only 3 points for me to dilate.
And you can draw straight lines.
And you can draw straight lines.
And not have to draw skinny
So
lines
we
with
have a triangle here. We're going to call this A. We're going to call this B. We're going to call this C because I'm super creative today. And we're going to dilate this with R equals, give me a fraction.
5, 6.
5, 6.
42 over 100.
Oh.
I like 5/6. Now, okay, so here's the deal. I can multiply by 2 in my head super well, actually. That's why I chose 2 for that, because I wanted it to be kind of quick to just show you. All right, this is how we do a circle. So I chose 2. I can't multiply by 5/6 in my head worth an actual darn. So we're gonna grab our calculators of joy and love. And is there a 5/6 button on here?
No, just divide 5 by 6.
This is a fancy fraction, so I'm going to say 5 divided by 6, and my R actually, 8. Not a pretty number. Can we deal with numbers that aren't pretty, though? We can deal with numbers that aren't pretty. It's 0.83 with a line over the top. One of you in this room, the other day when we were doing 1/3, he divided 1 by 3 and got 0.99 and didn't round and tried to tell me that 3 times 1/3 equals 0.99. It does not. It equals 1. So, and actually 0.9 onto infinity. I could show you a mathematical proof if you want, but 0.9 onto infinity actually does equal 1.
Oh yeah, because you can just take the 9 and round it up.
No, we're not even rounding. It equals 1.
That's 0.92.
You want me to show you real quick how 0.9 onto infinity equals 1?
Sure.
Everybody else, do you want me to show you real quick, or do you want me to do this stuff first?
Show it.
I'll do this stuff first, and then I'll show you the other stuff later, okay? So I'm going to dilate this by 0.83, and I'm going to do it in pink. And then we're going to dilate that by 6/5 and bring it back. It's going to be a little bit dicey because these numbers are awfully close to 1, so it's not going to be moving very far. It's not going to be getting very much smaller. So if OA is, I want you guys to all get your calculators out. If OA is 9 and R is 0.83 onto infinity, what's OA prime? Who can calculate that for me? And every student is allowed to answer once. So once you give me an answer once, I need somebody else to give me an answer. So if OA is 9, which it is, 9 centimeters, what would OA prime be? Casey? 7.5. Like I said, it's going to be super close. So there's A prime. Okay, so OB is 21.5. So let's do 21.5 times 0.83 onto infinity. Who can tell me what that is? What's OB prime? What is it, Max?
17.92.
So, okay, I'm just going to get as close as I can here, right? Like there isn't 0.92 on here, but that's B prime. Okay. And then C prime, we have 15.5. So it's 15.5 times 0.83 onto infinity. Who can math that for me? Not Casey and not Max. Braddock.
12.92.
12.92. So it's going to be right there. So I connect these dots, and I have
A tinier version.
a tinier version. And we know it's going to be smaller because 5/6 is less than 1. So this was 12.92. This was, what was AB prime? Do you remind me what that was, Casey? Do you remember? AB prime. Or OA prime.
7.5.
So that's 7.5. This one's 12.92. And what was OB prime, Max? Do you remember?
17.92.
The reason I wanted those is because when we go backwards, we can just pop those into our calculators to go backwards. So now I'm going to do it in black to go backwards. We're going to go from this one, the primes, to, I'm not going to go use black because my black marker isn't there. Oh, there's my black marker. I'm going to use black. So let's flip it. And now it's 6/5. So now R equals 6/5, and we'll see if it really does get us back to where we were. So what's 6 divided by 5? This one's going to be prettier.
1.2.
1.2. So now it's going to get bigger. Well, who can tell me what's 17.92 times 1.2?
21.5.
21.5, which is where it was in the first place. So B double prime is on the same place as B. What's 12.92 times 1.2? Braddock. 15.5, which is where it was in the first place. And this other one is going to be the same thing, where it was in the first place.
Yep, 9.
So, like, let's say I dilate something by 7/4. What would I dilate it by to get it back? We're going to pull some sticks. What would I dilate it by to get it back, Ronan? I'm dilating it by 7/4. What would I dilate it by to get it back to where it started?
4/7?
4/7. Exactly. You just flipped the fraction. If I'm dilating it by 5, what do I dilate it by to get it back? Sylvie. Remember, there's an invisible 1. Then 1/5. Okay. If I'm dilating it by 1/2, what am I going to do to get it back? Dave.
2/1.
Just 2/1, or you could just write 2. If you write 2/1, am I going to mark it wrong?
No.
No. But you could also just write 2. All right. How does everybody feel?
Good.
Pretty straightforward stuff today. Not learned a little bit new stuff, but not a lot. All right. Good luck. Let me know if you have questions.
Was number 2 optional?
No.